Hi everybody, now we are going to talk about the implicit differentiation, of course, of still the logarithmic function. And basically with the implicit differentiation, of course, when we have the variable y in our function and we need to get the derivative of y in terms of x, that's what we call the implicit differentiation. And let us first try to have this first example. Use implicit differentiation to find the derivative of 4xy plus ln of x squared y is equals to 7. So as you can see here on this part, we can be able to separate this into two. So it will become 4xy plus ln of x squared plus ln of y is equals to 7. And this exponent of 2 here, using our properties of logarithm, we can be able to use that and move it to the beginning of our natural logarithm and make it as use as a constant. So we will have 4xy plus 2 ln of x. So the 2 from the previous equation that serves as an exponent become 2 here, and the current equation as a constant in the beginning of our natural logarithm. So we have 2 ln of x plus ln of y is equals to 7. And on this portion here, 4xy, we are going to use the product rule. And we will gonna start to differentiate. So after using the properties of logarithm, we're gonna start to differentiate the equation. So first we have, you're gonna use the product rule. And first we have, of course, try to copy the first term, which is 4x times the derivative of our y in terms of x is dy over dx, plus our second term, which is y, times the derivative of 4x is 4, and then plus the derivative of 2 ln of x is 2 over x, plus our derivative for ln of y is 1 over y dy over dx. dy over dx, we put it here after 1 over y because we are going to show that we are differentiating the y here in terms of x. Then we have equals to 0. And next step that we're going to do is, of course, to collate it together. We're going to multiply this, then it will become 4y, and then this positive 2x, this terms here inside, we're going to put it or transpose it to the right side of the equation. Okay, so let us see. Let me just remove that. Right, so it will become just remain the 4x dy over dx plus 1 over y dy over dx. So we're just collating all of the dy over dx here at the left side of the equation, and we're going to move to the right side or transpose to the right side of the equation the remaining terms, right? So since here we have a positive 4y, when we transpose it to the right side, it will become negative 4y. And then the positive 2x here will become negative 2x. Okay. Alright. So what is the next step that we're going to do? We just focus in this part and then just combine dy over dx. So we're just going to factor this. Since we have on both terms we have dy over dx, we can be able to rewrite it as the quantity 4x plus 1 over y times dy over dx is equals to, I just copy that, negative 4y minus 2x. So next up, we are going to start eliminating those terms in beside the dy over dx. So we can be able to get the value of dy over dx. How can we able to do that? So we are just going to divide both sides by the expression 4x plus 1 over y. And then we can be able to cancel this too. And next we will have this kind of equation, which is dy over dx is equals to negative 4y minus 2x over the quantity 4x plus 1 over y. And then what are we going to do now? So we're going to get the difference of this numerator, and then we're going to get the sum of this denominator. First part, let's just first focus on this numerator. So negative 4y minus 2x. So of course, our common denominator here will be the x. So we'll have x divided by 1 is x times the numerator negative 4y. We have negative 4xy, and then x divided by x, the denominator of 2 over x, it is 1 times negative 2 is negative 2. Okay, so we're done with this numerator part. Let us focus now on the denominator and get the sum of it. And basically, as you can see here, we are going to use y as the common denominator. So y divided by the denominator of 4x, which is 1, is y, times 4x is 4xy. And then y divided by y is 1 times 1 is equals to positive 1. And next step, since we have division here, so we are going to get the reciprocal of our computed value for the denominator, and we're gonna multiply those two. So we're gonna multiply negative 4xy minus 2 over x times the reciprocal of this is y over 4xy plus 1. So just get it and multiply. Okay, so let's get rid of those. And then negative 4xy times y is negative 4xy squared. And negative 4xy times y, negative 2 times y is negative 2y. That's why we got this numerator. And then let's focus on those denominators and multiply, distribute x to the next terms. So we have x times 4xy is 4x squared y, plus x times 1 is x. That's why we have our final answer here. For differentiating the expression 4xy plus ln of x squared y is equals to 7, we're going to get our final answer will be dy over dx is equals to negative 4x squared minus 2y all over 4x squared y plus x. That's how easy it goes. Just follow those steps. On the beginning of the equation, think of any properties of logarithm that can be applied. After applying the properties of logarithm, then proceed to finding the derivatives or differentiate it. So just apply what rule can be possible to use, if it is a product rule, a quotient rule, or whatsoever. Alright, and then use also the basic factoring method and mathematics, and you can be able to get the final answer. So yeah, let's proceed to more of the implicit differentiation. Again with the chain rule, use of the chain rule. We have this example, y is equals to ln of the quantity x squared plus y squared. So first step is we need to get the derivative of both sides of the equation. So it will look like as d over dx of y is equals to d over dx times ln of x squared plus y squared. And then the derivative of y in terms of x is dy over dx. And next up, of course, we are going to apply the getting the derivative of natural logarithm, which is 1 over u times the derivative of a u. So in this next term, we have our u will become the x squared plus y squared. So that's why we're going to get the derivative of ln of x squared plus y squared. It will become y over x squared plus y squared. Okay, again, the u that we have here is the x squared plus y squared. Those terms inside the parentheses. And then next is we are going to get the derivative of that inside the parentheses. Okay, so first up is we're going to get the derivative of x squared is 2x. And then the next is the derivative of y squared. As you can, okay, let me just reveal it. So derivative of 2x derivative of x squared is 2x, and the derivative of y squared is 2y dy over dx. Why there is a dy over dx? Because we are implicitly differentiating it as well, because we have the variable y here. So to indicate that we are differentiating this y squared in terms of x, we're gonna put dy over dx after 2y. So we have the expression 2x plus 2y dy over dx. And of course, next step what we're going to do is to distribute and multiply those two numerator. So easy. We're just going to have this equation of dy over dx is equals to 2x plus 2y dy over dx all over x squared plus y squared. So we're gonna needing to get rid of this denominator. How can we able to do that? So let's see the next one or the next step. So in order to get rid of this denominator x squared plus y squared, we can also multiply both sides of the equation by the denominator itself. So multiply both sides of the equation by x squared plus y squared. So we're going to cancel this too. And next step that we're going to have, or equation that we're going to have, will be dy over dx times x squared plus y squared is equals to 2x plus 2y dy over dx. Alright, so next step that we are going to do right now is of course to transpose this to the left side of the equation, so that all of the dy over dx terms will be combined on the left side of the equation. Okay, and then will remain this 2x at the right side of the equation. So we're gonna have dy over dx x squared plus y squared minus 2y dy over dx is equals to 2x. And after that, okay, we're just going to continue. I rewrite it here already. And next stop here, we're just going to at least rewrite it in a organized and more organized way. Okay, and then include this minus 2y inside the parentheses. So we're gonna have dy over dx times the quantity x squared plus y squared minus 2y is equals to 2x. And of course, on the last part of the step, we're going to get rid of those terms beside the dy over dx in order to get the value of dy over dx. How can we be able to do that? So just divide it by itself, so we can cancel it. Divide both sides of that equation by the term beside this dy of the x, right? So we have x squared plus y squared minus 2y. So divide it by the x squared plus y squared minus 2y, as well as here on the right side of the equation, we need to put here, right? We need to divide this 2x as well in x squared plus y squared minus 2y. So we can get rid of this 2 here. And now our final answer will be dy over dx is equals to 2x over x squared plus y squared minus 2y. Okay, so let's see more example of derivative of logarithmic function in case that you would like also to have more example of this will be a simpler one. Okay, so if ever we are tasked to get the derivative of y is equals to ln of x squared times sine x, so just use also those steps that we have done before, like apply those properties if needed, if you are going to, or if you need to apply the properties of logarithm, and after applying, solve, differentiate the equation, and use or factor it out if ever you need it. Then there you go. Okay, so we have ln of the quantity x to the 4th times sine x. So we're just going to distribute this ln here and then here, and then we're going to have this. Why we have this plus sign instead of the multiplication sign? It's because we apply the properties of logarithm when we have the product of logarithm. We can rewrite it as the sum of a logarithm. That's why we have y is equals to ln of x to the 4th plus ln of sine x. And then again we can apply another properties here. So what do you think? This will be this exponent 4. That's right. So we can move it to the beginning of our natural logarithm and use it as our exponent. Use it our constant. So from the exponent 4, we can just move it to the beginning of the natural logarithm and put it as a constant. So we got the y is equals to 4 times ln of x plus ln of sine x. And there you go. We are going to start now differentiating this kind of equation. Okay, and let's see. So we're just going to get this one here. So we have 4 times the derivative of ln x will be 1 over x. Okay, as you remember, when you are getting the derivative of a natural logarithm, just use 1 over x. All right, and then plus the the derivative for ln of sine x will be 1 over u times the derivative of u, and our u here is the sine x. So we're just going to write sine x as our u. Okay, so we're going to substitute sine x and our u. Then we're gonna get this 1 over sine x times the derivative of our u, or the derivative of our sine x, will be cosine x. And when you're going to multiply this, of course, numerator to the numerator, you're going to get the cos x over sine x. Alright, and then just take a look here. You're gonna use an identity here. Okay, for our trigonometric identity, and the identity for cosine x over sine x is cotangent x. We just multiply this with this 4 to 1x. So we have 4 over x plus cotangent x. So it means our derivative for ln of x to the 4 times sin x is 4 over x plus cotangent x. So this will be our final answer. Alright, so that will be all. I hope that you enjoyed the learning for today and God bless you. Thank you.